Hey guys, welcome to the channel again. This time we have a laptop in front of me, and that's an Asus laptop model M509D. Just to be frank, I fixed the laptop already, so I have the back cover already unscrewed. Let me put it aside. And so what was wrong with the laptop? So basically I bought it as a faulty. I got the entire laptop with the battery, RAM, SSD, everything was inside, Wi-Fi. I also got the power supply, power adapter, so but the laptop was not working. So the story of the repair of this laptop is not very interesting. I mean, it's not super exciting. So basically I did the basic measurements of the resistances, and I noticed that there is a short on this coil here. Turns out it's 1.8 volt, and so I injected the voltage and found out that this chip over here is getting hot, and that's the buck converter that is creating this 1.8 volt voltage. So yeah, so basically it took me like 2 weeks. I ordered the chip from AliExpress. I replaced it even without taking the board out. I didn't like remove anything from here. I just replaced the chip, cleaned the flags, and the laptop works. But what I wanted to show you actually is, so the laptop works, but I wanted to show you an issue. I would say is a factory issue. So the problem is that the heatsink on the CPU it's not on at the moment. I will reassemble the laptop fully and show you, but the heatsink is super small, so it's just a piece of like small heats, small copper plate and tiny flat heatsink on top of it. So the idea is that the air should flow from the fan here, and with the cover on it's actually like an air duct here, so it should exhaust the hot air outside. But the problem is it's actually not working as expected, so I don't know why Asus did it. I understand it's cheaper to do it like this, but it's actually killing it's like suffocating the CPU and the laptop, and so it's not even working like at 50% of its potential. So really I don't understand it. I know it's cost effective, but how can you give something like this to a client? It's just not working as expected. So see you guys in the next part. I will assemble the laptop and show you what the problem is. Okay, so I have the laptop running. It's not screwed underneath, but the cover is put on because, as I mentioned, it requires this kind of, it requires to be covered in order to get the directed airflow from the fan. That's the assumption at least, but well, it's not very good assumption because, so as I said, the laptop is working fine, although everything is super slow. At first I thought it's caused by the hard drive maybe, but I tried the same SSD in another laptop, works perfectly fine. So it's not the Windows issue, it's not the SSD issue, but what you can see here, you can probably see the problem already. So even without, I'm running Cinebench right now, so but even without it, the temperatures are around 90 degrees, as you can see, the package temperature. So maximal was 94 degrees, right now it's 93. And the other problem related to this one is the core speed, the core clock. So the max was around 2 gigahertz, even above 2 gigahertz, but that was probably only for a moment when I started the laptop while it was still quite cold, and I did run the application, the hardware monitor, but as you can see right now it's throttling really bad, and it's like constant 400 megahertz. It was even 350, so very bad throttling, and no wonder, because of the temperature it won't go any higher. So I think I have an idea. That's quite an experiment, because, well, laptop like this, it won't work. Okay, it's useless, and you know, it has a decent processor, Ryzen 5 3500U. It's a decent processor. I had plenty of laptops with this processor, and it's quite capable. It's really snappy, works fine when provided a decent cooling. And you have seen the cooler on this laptop. It's just wrong. Okay, so I have the laptop open at my desk again. So what I mentioned is that the the heatsink is very tiny, and the idea is that the airflow from the fan will go like this and take away the heat from the heatsink and exhaust it here that way. And for that you need a cover on the laptop, so once it's covered like this, there theoretically should be like a airflow, directed airflow here, and should exhaust the hot air. But as you could see already, it's not sufficient. It completely doesn't work. So like the CPU is actually not running at its full potential, not even like a little bit. So what I want to do, some time ago I bought, just for this one, just for this purpose, I bought like a old heatsink from another Asus laptop. I mean, it doesn't matter, it's Asus. I just bought it because I thought it might fit. So actually I have it here. So it was something like this. So this part here actually connects, is put on the CPU, and then there is a heat pipe, and at the end of this heat pipe, because I already destroyed it off camera, there was this small heatsink as well. So it was like this, but here it's from an older laptop. Is it okay? Yeah, I think it was like this, but here it won't fit. I won't put the cover on if it's like this, so that's why I removed this. I don't think we have any use of it, because even if I put it like this, it just won't close the cover, so it doesn't make sense. So we don't need it. Maybe I could figure out something with how to attach it. There was this bracket for the processor, but it won't fit in any way here, so I think it doesn't matter. So what I wanted to do, actually, my idea is to put it like this. So I made a scratch here to be in the center of the heatsink like this. So I want to solder it. So here is the copper plate underneath, and some silver metal here. But I think if I could solder to this properly, if I could make it like this, that would be, I think it could be much better. So therefore will blow on the heat pipe and this copper shim here. So I think that should be a lot better. Of course, you may say that it will cause a short. Of course, you're perfectly right, but of course I will cover this part of the board with some tape, and here as well. So everywhere where the metal parts are, I will cover this underneath, and here. That's the idea. But let me unscrew the heatsink, and meet you in a second, and we will do some soldering on video. Okay guys, so that's the first time I'm doing something like this, so I don't really know what's the best way to do it, to be honest with you. Because I could either use the soldering iron, or I could use the hot air station, or maybe a mix of both. I don't know yet. What I will try to do, what I need to do basically, so we want to solder it here to this part, so like this, I think, yeah, it was like this, yeah. So it's positioned the same way as on the laptop, like, I mean, the numbering on the screw holes here. So yeah, it should be like this. But first let's put some flux on it, because without flux it won't stick, the solder won't stick. And here are the copper holes, copper bolts, whatever you call it. So we need a lot of flux, or maybe not that lot, but yeah, quite a lot of flux. And we want to cover this entire area with the solder. And in order to do that, you need probably a lot of heat. So I will need this to hold it, because it will be very hot, even if I hold it like this, just to stay in place. And I also need a special tip on the soldering station. So the biggest one I have is this one. It's a really thick boy. Yeah, let me open the window. Actually, I don't want to use the fume extractor, because it's gonna make some noise, and I think we are good. Maybe I'll do it like this, it will be easier to hold for me. And what we need now is a lot of solder, a lot of solder. So I'll melt the solder wire, like a lot of it, like really a lot we need here. Okay, yeah, we have it. So now let's try to cover it with the solder. It needs to soak the solder. It needs to soak a lot of heat to be able to absorb the solder. Is it? Yeah, I think it's okay. So the bolts here, you can see it has the solder on it already. Now we need this one here, okay, and this one. Oh, that's a lot of smoke. Okay, I need a fume extractor, sorry for that, but I just hope it's gonna be enough. Honestly, I don't know that. Maybe I could put a little bit here as well. Here on the top, so somehow it will connect to here as well. I don't know. Let's try it. Not, as I said, doing it for the first time, not sure if it's gonna work, if it's gonna stick even. Oh, okay, it's nice and white, so maybe we can somehow enhance it. Okay, what about here? Is it covered? No, it's not sticking at all. Okay, that should be enough. I mean, let's try. So we have the flux. Maybe I'll remove the excess of the flux. Hope you can hear me talking, not the fan noise only. Okay, let me clean this. It's burned, so we don't want it. It's not nice. Let's remove as much as we can. Okay, put some more. Let's do like this. Oh, it's hot. Okay. Yeah, but we have solder bubbles, and I think it's solid. It looks solid. It's connected to this, so I think those could be the anchor points for our soldering. Let's see. What I need to do as well is okay, so it's somewhere here. Let me scratch it with the. Need the mark like here. Okay. Somewhere here. And then we need to cover it with the solder as well. It will make it easier for us to actually solder it together. So let's put the flux on it. Okay, like so. And then we come again with our trusty solder guy, solder tip. Okay, and now it's gonna absorb a lot of heat, so I just need to hold it like this until the solder melts and the pipe actually absorbs enough heat to be able to stick some solder to it. I need more solder, I think, like so, a lot of it, and get back on the heat pipe. Yeah, it requires a lot of heat. Look, it just starts to melt. I'm wetting the heat pipe with the solder, like that. Really nice. Okay. Okay. All right. We got. Ah, shit. Yeah, I knew it will happen. So, because of the temperature in the pipe, it actually moved the shim. Let's solder it again in place like this. So I need to do this again. Give it a lot of temperature so it melts together. It's not that easy. I mean, I don't know if it's okay or not. Oh fuck. Wow, I haven't expected that. That was really surprising and possibly even a bit dangerous. Good I had the glasses on. Anyway, so I think it's no use for us now because it's like swollen, like the pressure inside it kind of like made it bigger, and it exploded, so I think it's now useless mostly. But I mean, maybe we could use it, I don't know. But what I'm thinking about doing now, just for science, to get this copper shim and put it on top of our original heatsink. I mean, it's comparing to this entire heatsink, it's quite substantial, I would say. So maybe if we could get it on top like this or like this, I don't know which one is better. Maybe like this. So then I think maybe it will increase the cooling. Actually, let's see for science. So I'll solder it together with you, and then I'll cool it down, and we'll meet in the video with the heatsink on. Improved heatsink. Let's see if it changes anything. So first I need to get some solder on the tip. Okay, it's getting hot. A lot of solder, and now I need to put it on this. The good thing is that it's actually easy to cover with solder, like you've seen before, this part, so we can wet it all, like every piece of it. A lot of smoke, but it's nice. It's covering really nicely. Okay, we need a lot of solder. Maybe we need some more. I need fume extractor again because it's too much smoke. Okay. Yeah, it's fine. Whoa. It's really hot, so I wouldn't touch it now with my hands. Okay, let's quickly clean it. I need a cotton swab or two. remove the burnt flux. Okay. Okay, that should be enough cleaning for now, and we need flux again on top, like so. Alright, and now we put the copper shim on top. Here is a lot of solder, so I think it's gonna go this way. I mean, it doesn't need to look pretty, but I want it to be solid and maybe increase the cooling if we can achieve it. So, alright, and what I will do now, I will just stick it again on this side, transfer the heat, and so it should melt to the heatsink below. I'm not sure if it's melting because I cannot see it right now. But yeah, I guess it will start smoking when it's ready. So. Oh, it's starting to smoke. I think the solder is getting wet on this side. Let me check. Is it melting? Not yet. Yeah, it's a lot of copper, unfortunately. Yeah, I think it's melting now. Okay. Let me remove it. Let it cool down a bit. I mean, it's not pretty, it's not super even, but I guess it doesn't matter that much. That's a lot of smoke. Actually, let me move it here. Okay, is it solid? Yeah, it is solid. Okay, I can lift it like this, and it's connected to the heatsink. Okay, all right. So let me pause the video and see you in the next part where I will try this heatsink if it's any better than the original one. Thank you. Okay, so the modified heatsink is on. The laptop is running again, and well, first of all, I would like to say that the Windows was a lot snappier. Like, I could normally use it, like everything was smooth and then working fine. And now I'm running Cinebench, and I've run Cinebench once already off camera, and now I'm running it again just to show you stuff. So what you can see, first of all, the boost clock. So those were the max boosting clocks, and that's pretty high. I think it's a lot higher than the CPU is rated for. So it was just for a moment at the beginning when the heatsink was actually cool, but now it stabilizes around 1600, 1800. So I mean, it's not perfect, and I feel it's still insufficient, but it proves my point that we were thermal throttling. And also what you can see is the temperature, the package temperature. It's less than 90 degrees, and it was maximum 22 at some point, but it's actually pretty stable here with, sorry, let me focus again, around 90 degrees. And as I said, it's pretty stable. It's under full load right now, so it looks definitely better, and it's holding the boost clocks around 1800 all the time. So yes, it's not sufficient. I think I will work on the heatsink, so try to improve it even more, so maybe solder some additional heat pipe or something like this. But obviously the one that just exploded on the video is not good, so I think, I will just buy some or find some scrap heatsink I could use and modify it so we can improve the cooling on this thing, because this processor has a lot more to offer, and I think it would be a shame throttling it like this.